Okay, guys. So my voice is completely clear. My voice is completely clear to everyone. Right. Okay. Great. So for the today, I'm just going to discuss about the exam paper. How will be your exam paper? Okay, and how will you be able to solve each and everything? Uh, First, I am just explaining what are the main components of your exam paper. Your paper consists of the 20 questions. 10 will be MCQ and 10 will be solving, and you will have 2 hours to solve them. So for you, the first thing to do your paper is the time management, how to manage the time for doing the exams. Okay, so how will you manage the time? How will you be able to manage the time? And there are few more important parts, I will explain them there. Okay, so the first thing, you will do MCQ. Just remember, they are only 10 MCQ, so you should need only 20 to 30 minutes to solve all 10 MCQs only. Don't take a lot of time. If you know, do it. If you don't know, just leave it for the later. Okay, if you know, do it. If you don't know, just leave it for the later, but don't waste your time by doing only MCQs. Okay, then you will come back to the solving. You will have 1 hour 30 minutes for solving the 10 questions. It means you are going to have 90 minutes for solving 10 questions only. Few questions are very simple, very simple, just answering them, naming them, that's it. Okay, but few questions are time taking, so we will see how we will be able to do that. Now see, it's I am starting the paper right now, and you will see that we will finish the exam paper with less than 1 hour, inshallah. I will try to finish as soon as possible. Okay, I will take a little more time because obviously I have to explain the topics. So let's start with this question. So the question is visible to everyone. Is the question is visible to everyone? Can you able to? Yes, there will be 10 MCQs in the starting of paper, inshallah, and 10 questions for solving. Okay, visible. Yeah, great. So let's start. Let us start it. The saline solution of the homogeneous mixture of sodium chloride and the mixture of 85% of the mass contributed by the NaCl. What mass of the NaCl is found to be in 2550 ml of saline solution? The density is this. 0.85%. 0.85%. Remember, guys, if we talk about the percent, the word cent, percent, this cent means 100. Okay, and the density is 1, so it 0.85 means 0.85 gram of sodium chloride, which is the salt you use in the food, is present in 100 gram of H2O. The density is 1, so you can say the 100 ml of water. 100 ml of water. Okay, so it is given, and what you have to find for 255 ml. Okay, the what formula I will use here? Okay, the formula for these kind of the question, see, this is the question of relation. The first relation is given that 0.85 gram is present in 100 gram, and now you have to calculate for 255 ml. This question is the for relative question. You have to calculate the relation between them. So for these type of the question, just equate them. How? The mass of NaCl divided by volume of water, it will be equals to the mass 2 of NaCl divided by volume of H2O. This is the second volume. Okay, this is the just a second. I'm also at the same time I will tell you the how it will be, like how it will be means that this chapter is from this question is from chapter 1 and chapter 2, because chapter 1 2 is combined for you. Okay, so how we will use this. Okay, how we will use this, just a simple one. 0.85 divided by 100 will be equals to mass we don't know, which is W, and now divided by 255. So it is 0.85 divided by 100 multiply by 255. Can you calculate the answer? Can you calculate the answer? Can you be able to calculate the answer? Someone asked me why we have to divide it by 100. We have to divide it by 100. Can you explain again from where we get the V1 of H2O? My friends, wherever the percentage is given, 0.85% is given. So percent means that this amount is present in every 100 ml of water or something. So the word percent is telling you 100. Okay, the word percent is telling you the 100. Got it? Did you got my point? Great. Great. Someone asked me that from where 0.85 came. The 0.85 came from the percent. The percent is given there. So from that part it is given. 2.16 is the answer, and the nearest answer is 2.2, which is the correct answer. Okay, the correct answer is C, 2.2. Let's move to the next question. Here is the next question. These questions are from chapter 1. Okay, so don't be confused. Okay, the student are allowed to measure the freezing point of the water in the laboratory. The result as follows. So they are getting the freezing point like this. Like, but the actual freezing point is 0. What are the results these students can show? Remember, if the students are getting the answers almost same, almost same, like for example, other students are getting 2.86, 2.85 and 2.84. They are almost same. So if the values are almost same, it is called precise. Okay, it is called precise. If the students are getting the values nearly equal to 0.0, like 0.01, 0.00 minus 0.01 or 0.02, they are actually also precise because they are near values, and also they are accurate because they are matching with the main things. Okay, so you got the difference between the precise and accurate. Okay, now see, the values are 2.86 minus 4.52 or 3.21. Wallah, the values are one value here, one value there, and one value there. It means that first thing, they are not precise. Why they are not precise? One value here, one value there. Wallah, very big difference between them. That's why they are low precise. They are very less precise. Also, it is very far away from 0.00. Okay, very far away from 0.00. That's why it will be low accurate and low precise. Did you got my point? Did you understood the question? Yes, we are recording the session. Don't worry about that. It will be available to you after the class. Did you got the point? Did you understood? Easy question. Wallah, these questions will not take a lot of time. Okay, these questions are all really easy. Now, another question. Let's come to the next question. Okay. For this question, guys, I will tell you the formula which should be used here. Okay. The formula which should be used here. Always remember, my friends, always remember, whenever you see the question of the isotopes. Okay, isotopes means I'm I'm Adeel. Okay, there are 3 Adeels in front of you. The first is the small one, the second one is the bigger one, and the third one are the larger one. But all 3 are Adeel. Okay, it means that, what does it mean? It means that isotopes are those things which are actually same but do have the different masses. Okay, first is a small one, the second, see, for example it is here x28, x29 and x30. All of them are x, but they are 28, 29 and 30 different masses. Okay, you have to calculate the average atomic mass. So for average atomic mass, the formula here, remember, submission of, okay, this is the symbol of submission means addition of everything. Okay, submission of m1 and p1 divided by 100. That's it. Just put MIPA. Okay, for this we have 3 x's. It means the formula will be m1 p1 divided by 100 plus m2 p2 divided by 100 plus m3 p3 divided by 100. This will be the formula which will be used to everywhere to calculate the average atomic mass. Okay, please calculate here. Please calculate the mass. How you will calculate? There is a question, how we will calculate if we have only one answer per student. If you get only one answer for one student, no one will be able to tell it is precise or not, because to be precise we need 3, 4, 5 values. Okay, we need 3, 4, 5 values. To answer for calculation for okay, for the calculation of precise thing you need 3 to 4 values. Okay, but for accuracy you need only one, because you have to check whether it is original and whatever you calculated it's near or not. Okay, so let's move on. Yes, so what answer you got? See, most of the students, what they will do, they will just write the equation and like this, and now I will write the equation like this, multiply by this, no, you don't have to do this. Wallah, this is MCQ. No one is asking how you do that. Okay, you have scientific calculator. Everyone have scientific calculator. So just write all the equations directly in the scientific calculator. How? 28.976 multiply by 4.7 divided by 100 bracket plus and so on. Just write this in the scientific calculator and you will get the answer. every question of average atomic mass will be same. Every question will of the average atomic mass you will get the same. Did you understood? Did you understood, guys? Did you understood the formula? If not, then tell me. If not, it's okay. Okay, great. It is the simple formula which you can use here. Very simple formula. Okay. Now let's move to the next one. Let's move to the next one. This is from chapter 10. This is from chapter 10. Remember, guys, remember this thing I told you in the previous sessions also, and also I'm telling you. See, temperature is given, volume is given, pressure is given. After that, temperature is given and pressure is given, and you have to calculate the volume. So temperature, pressure and volume, this relation you have to find. I told you, or if you don't know, just write PV by T equals to PV by T, or you can say P1 V1 by T1 equals to P2 V2 by T2. Just calculate the answer. Just calculate the answer. This will be the formula. This will be the formula. How you will do that? How you will do that? Just you have to calculate this V1. Okay. And for P2, it is here P2, pressure 180 m. For volume, volume is here. T2, temperature is here. P1, pressure 1 is this. Temperature T1, temperature 1 is this. Just calculate the volume here. Very, very simple. The main thing here, only just to remember the formula. Okay, when you will put in the scientific calculator, wallah, you will get answer. Tell me if you are confused. Sometimes the percent is not given. On which question? On which question the percent is not given? For the question number 1 or the question number okay, the previous question. Okay, no problem. Let's come back. Always remember, my friends, if sometime the percentage is not given, formula will be this. For example, you have to calculate the percentage. Okay, let us consider I'm giving you a question. See, the average atomic mass of chlorine is equals to 35.45. okay, this is the average one. Now the isotope 1, I1, or you can say Cl, it has mass of 30, let us consider 34. Okay, and the second one, make it 35. Okay, and we have the second one, second chlorine. The second chlorine, okay, the second chlorine, it is 37, and you have to calculate the percent. For this one, use the same formula. You have to calculate the percent of this and percent of this. See, remember, always all these percentage like x plus y, it will always be equal to 100. Okay, for y you can be able to write 100 minus x. Okay, from this formula. For y, just write this. Now use the same equation. Use average atomic mass, which is 35.45, equals to m1. m1 is 35, multiply by p1. p1, let us consider x, divided by 100, plus the m2 is 37. What is the percentage? Y, and y we put is 100 minus x. 100 minus x divided by 100. Will you be able to calculate for x? Will you be able to calculate for x? Yes, these are the percentage of isotopes. These are the x is the percentage of isotope. Well, the formula will be always same. Okay, So you don't have to remember, you don't have to worry a lot about that. It's easy, it's not very complicated. Okay guys, if the meeting link over, please join again with the same link. Okay, because as you know that Zoom link sometime it expires after 40 minutes, so just join the same link. My link never changes. Okay, so let's move to the next question. Okay, so did you understood this question? Did you understood this question? The simple, very simple, P1 V1 by T1 equal to P2 V2 by T2. Halas. Very simple. Did you understood this? Okay, cool. Nice. So let's move to the next question. Let's move to the next question. Someone is asking me for this question why you put 35.45. It was given in the question. For me, okay, if see, there are only two things can be given. Okay, the answer, the approximate answer, it should be 75% here and 25% here. The answer should be like this. Okay, and this is the plus should be here. Okay, this is the combined one. Okay, and where 35.45 it was given in the question. This question either you have to calculate the percent or you have to calculate the average atomic mass. If the average atomic mass is given, you have to calculate the percent. If the percent is given, you have to calculate the average atomic mass. These are the only two things that should be here. Okay, most of the time, 99% times, this type of the question will be there. This type. Okay, because you have to calculate the average atomic mass. 99% in the even in the previous exams with the UAE University also, in the previous sessions, in the last year exams, the question was like this. Okay, because they don't want to make everything so complicated that the students will not be able to do them. Okay, so don't worry, the exam paper will not be very tough. It will be good. Now see, aqueous solutions, chapter number 4. First we will study about the concept here. So let's see if anyone having, okay, everything clear till now? Should we move on? Okay, great. So chapter 4 and question number 5. Question number 5 says that how you will be able to classify them. Okay, remember, see, I will explain every part of this question, and finally when I will explain everything, you will tell me the answer. You all will tell me the answer. Okay, not by looking at this, because obviously the answer is given, but by thinking and by the reason. Okay, now see, what are acids? Remember my friends, anything having H and some non-metal here, any non-metal, NO3, I, ClO4, Wallah, HCl, HBr, and HNO3, H2SO4, HClO4, HClO, HBRO, HIO, everything starting from H, acid. Wallah, it will be acid. Okay, non-electrolyte. Remember, all those things which are made of, except acids, all those things which are made of non-metal and non-metal, like for example CCl4, CH4, CO2, non-metal, everywhere non-metal, wallah, no problem, mark is as non-electrolyte. For example, glucose, C6H12O6, this will be non-electrolyte. Now, a strong electrolyte. Remember who are strong electrolyte. All the ionic compound who are ionic compound made with metal and non-metal? Sodium chloride, potassium bromide, rubidium chloride, francium chloride, any metal and non-metal or ionic compound. Plus all strong acids, all strong acid. Who are strong acid? Nitric acid, sulfuric acid, HCl, HI, and so on. Okay, these are strong acids. And all strong base. Who are base? Base must have OH with them. NaOH, KOH, calcium hydroxide, aluminium hydroxide, wallah, they all are base. Okay, so who all are ionic? They will be the strong electrolyte. Now check the question. HNO3, oh my god, acid, which is a strong acid. HI, also acid. Okay, no problem. HClO4, also acid. But KBr, wallah, KBr, I told you who are KBr. KBr is the one who has ions, metal non-metals. RBCl, again ions. So ion plus acid, it will be strong electrolytes. Okay, soluble salts, they are ions. Who ion? Metal and non-metal, which are not precipitated. We will talk about later who are precipitated, but especially the soluble salts are made of ions, which is metal non-metal only. How about the weak electrolytes? They are weak acids and weak base. Who are weak acid, weak base? NH3 is weak base. CH3COOH, this is weak acid. HF, remember guys, hydrogen fluoride is a weak acid. H3PO4, these are the weak acids. Mark them with important, wallah, very important. HF is the weakest acid. H3PO4 is also the weak acid. HCN, these are also the weak acid. Okay, so these are the, if weak acid or weak base, weak electrolyte. Soluble salt are the made up of ions. Okay, normal salts. Strong electrolyte is a mixture of ions and acid. Non-electrolytes, wallah, all the non-metals except acids. And acids, I told you who are acids. Everything clear? I need the answer from every 4 students who are present here. Everyone. Everything clear? Should we move to the next question? Okay, great. Examples of the non-electrolyte. The examples of the non-electrolyte, like CH4, methane, okay, and C6H12O6, glucose, fructose, any organic compound, methane, ethane, propane, butane, pentane, hexane. You remember organic compounds? Okay, they all are non-electrolytes. Okay, let's move to the next question. I'm telling you again, if okay, the Zoom link is disconnected. Let's start it again. So okay, join everyone fast. Okay, okay, great. Everyone is back. Let's see the next question. Let's move to the next question. Everything is going good. Mashallah, are you comfortable? Are you feeling better that you know everything? You will be able to do the questions if these questions will come. Are you feeling confident? Everything is going fine. Little bit scared. I understand. Little bit scared. No problem. Inshallah, you all will do best in the exams. I was supposed to start these sessions before Ramadan, but due to some circumstances, I was not able to start them. Okay, fine. The question is from chapter 5. The chapter is thermochemistry or thermodynamics. This question very important and very easy. Very important but very easy. Very good. Very good. Delta U equals to Q plus W. For simple, the first law of thermodynamics, which says that U will be equals to Q W plus Q. Remember now. Remember, guys. Remember. If the U is released, it means the energy is released. Okay, it will be always negative. If the energy is absorbed, it will be positive. Remember them always. If we talk about the Q, or you can say heat, or you can say enthalpy, okay, or you can say also delta H here, enthalpy. Okay, so if the enthalpy is released, either released or you can say exothermic, it will be negative. Okay, if absorbed or endothermic, it will be positive. These positive, negative, wallah, they are very important, because if you will change them, everything will change, your answer will be wrong. Okay, if we talk about the work done, if the system is doing work, if work done, who is doing the work done? Work done by the system. System means whoever we are taking in the container, or whose reaction are we are performing. Okay, whatever we are observing, that is the system. So if the work done by the system, then work done will be negative. If we are doing work done on the system, it will be positive. Work done by the system, or you can say work done. The system will do work where? The system will do work on the surrounding. Because I am the system. Okay, if I am doing the work, I am doing the work on surrounding, it will be negative. If the surrounding is doing work on me, then the work done is positive. Okay, and this will be the formula. Let's come back to the question. The value of the U for the system is, you have to calculate the delta U. Okay, this one, 111 kilojoule of the work on its surrounding. Work on surrounding. Who is doing the work? Tell me, guys, who is doing the work? Friends, tell me, who is doing the work? Wallah, something is doing work on the surrounding. Who is doing work? Very good. The system is doing work. And if the system is doing work, what will be the value? Positive or negative? If the system is doing work, very good, the negative one. Value will be negative. It means that it will be minus 111. Now, it absorb 89 kilojoule of heat. It absorb 89 kilojoule of heat plus 89. Calculate. Fast calculate. Wallah, the answer is minus 22. Simple. Easy. Understood? Wallah, easy. Everything will be easy like this, inshallah. Just check what is the basic concept behind the paper. Okay, what is the basic concept behind every question? Shall we move to the next question? Guys? Okay. Okay. See. Chapter 1. Mole concept. How I know the mole concept, wallah? Because you think that Sir, you are having the very good degree in chemistry. You know everything. Ask me how I know everything. How I know this is from mole concept. See, if the gram is given and you have to convert it the number of atoms or the number of moles, it will always be the mole concept. Okay, from gram to mole or mole to gram, mole concept. Formula. The formula for this question is number of moles will be equals to given mass divided by molar mass. Okay, but here first we will see gram of complete fructose is given, but the question is asking about the only the number of hydrogen atom. What we will do, sir, full molecule is given. When I will calculate the number of molecules, I will just multiply it by 12 because every molecule has 12 hydrogen here. See, just calculate now. Let's come back. What is the given mass? 15.01 divided by, what is the molar mass of the fructose? It is 180. I am telling you, you can able to calculate. Wallah, it is easy, not a big deal. Everyone knows about this. In school you did. Okay, so this divided by 180. Answer. Tell me the answer fast. Guys, tell me the answer fast. Wallah, tell me the answer. My friends. Are you sleeping? No, you are the good. Yes, very good. 0.0833. 0.0833. Very good. 833. Now, I told you this is the number, this is the moles of the molecule. Now, if I want to calculate for hydrogen, what I will do? Yes, what I will do for hydrogen? Simple, multiply by 12. So 0.0833 multiply by 12. Multiply by 12. Tell me the answer. Tell me the answer fast. Tell me the answer. 1.008. Very good. Answer is 1.008. Sir, 1.008 is not available. My friends, this is number of moles. Okay, this is number of moles. I have to calculate the number of hydrogen atom. So remember, number of moles will be equal to number of atoms divided by Avogadro number. So it will be number of atoms divided by Avogadro number. So Avogadro number is what? 6.022, and by 6.022 into 10 to the power 23, when it will come there, so n will be equals to 6.022 into 10 to the power 23. Well, did you understood the question or not? First, what I did? First, I calculated the moles of this, then converted into the moles of hydrogen by multiplying by 12. Why 12? Because 12 is here. Okay, and now simply I have to convert into the moles into the number of atoms multiplied by the Avogadro number. You will get the answer. Here is the answer. Did you got the point? Okay, you want to repeat the last part. The last part is you calculated the moles of molecule, then you calculate the moles of hydrogen. So now you have moles now. Now you have to convert the moles into the number of atoms. So how you will calculate? Remember, moles multiply by Avogadro number equals to the number of atoms. Finish. Khalas. Very simple. Okay. Very simple. Shall we move to the next question? It's not divide, my friend, just multiply it. Okay, it will be multiplied. It will not be the divide. Yes, n by Na is equal to n. It says that n is equals to n by Na. You know this, you know this. What you will do? Just multiply both side by Na. So Na will be cancelled like this. So it will be this. Simple. Yes. Let's move to the next question. Let's move to the next question. Chapter, I think chapter 2 or chapter 3, I think. Chapter 2 or chapter 3, I think. Okay. Simple. Very simple question. Wallah, very simple. See. For this question, the nitrogen contains, okay, there is an oxide of the nitrogen which contain this percent of oxygen and the molar mass of this. What is the molecular formula? Wallah, very, very simple. Very, very simple. It is already telling you in the whole molecule 74.1% is oxygen. Simple. Okay. Okay, it is already telling you that in the complete molecule 74.1% is oxygen. Okay, no problem, sir. I will calculate. Just 108 multiply by 74.1%. Tell me the answer. Tell me what is the answer came here. Tell me what the answer is here for this question, for this calculation. What answer you got? 80. Almost 80 is the 80 came. 80. It means that in this molecule 80 gram is oxygen. Oh my god. I remember one thing. Sir, given mass by molar mass equal to number of moles. What is the molar mass of oxygen? What is the molar mass of oxygen? What is the molar mass of oxygen, my friends? Almost 16. 16. Just calculate. Wallah, 80 divided by 16. 5. In which molecule you are looking oxygen is 5? In which molecule you are looking oxygen is 5? Wallah, A. Wallah, simple. Again, I am telling you what I did. The whole molecule has that percent of the atom. Now what I did, just multiply both of them and divide it by 100. So you got the percent, the mass of that element. Okay, because the percent was given for the this oxygen. Oxygen is 74.1%. So the mass come was the mass of the oxygen. Now the given mass is given divided by the molar mass. You will get directly the number of moles. Simple. Did you understood this? Guys, did you understood this question? Shall we move to the next question? Why did you use the mass of the oxygen, not nitrogen? My friend, I use this for the oxygen because the question is asking about the oxygen. Reason. I gave you, for example, I have something in my pocket. Let us consider I have Indian currency. I gave you that. When you will receive the Indian currency, everything you will check in the Indian currency. Whatever I give you, you will give the answer of same question. Okay? If I will ask you about UAE, you will give me the answer related to UAE. So if the question is giving you the information about the oxygen, that's why I will use everything related to oxygen here, and that's why I use the mass of the oxygen. Second thing, only oxygen is here whose value are different in every molecule. Only this one is same, otherwise it is different. Okay, so that's why I use the oxygen as the base to do this question. Okay, for example, if this is not the multiple choice, how can you will find the subscript for the nitrogen? Very simple, very simple. This is the oxide of nitrogen. It means it has only either nitrogen and either oxygen. The oxygen is 74.1%. Very good. Tell me how much nitrogen is present. Tell me how much nitrogen is present. Wallah, it will be 25.9%. Obviously 25.9 nitrogen plus oxygen 100%. Okay, so do same thing. Do exactly the same thing what we did here. What? 108 multiply by percentage of nitrogen 25.9 divided by 100. Whatever the answer is here, divided by the molar mass of nitrogen, molar mass, which is 14. Okay, and you will get answer 2. I am 100% sure. Yes, yes, yes. Okay, let's move to the next question. Okay, let's move to the next question. Okay, for the energy level diagram, you have to remember few things. Okay, you have to remember few things. First, if the arrow is going up, it means absorption. Okay, absorption. Second thing, if the arrow is going down, it means emission. Third thing, one second. Okay, just a second. Yeah, third thing, remember that if the energy is here, obviously this is written, if the line is long, more energy, if the line is small, small energy. This is the simple thing you can see here. But energy is inversely proportional to wavelength. If the energy is greater, the wavelength will be smaller. If the wavelength is smaller, energy will be smaller, the greater. Okay, now read the question. The question says that the following diagram of the energy level transition of the hydrogen atom, which transition represents the emission? Downward arrow only. This one, no. This one, no. Either C, D, or E. Okay. Shortest wavelength short means energy maximum. Who has the maximum energy? Wallah, tell me, guys. Who has the maximum energy? Who has the maximum energy? Very good. The D is the answer. D is the answer. Since the arrow of the D is smaller. Simple. Yes. Shortest wavelength. Yes. Shortest wavelength means great energy. Maximum energy. Okay. Short wavelength means maximum energy. And maximum energy, longer line. Long line, D. Finish. The third point, I said that the energy is inversely proportional to the lambda, which is wavelength. Energy is inversely proportional to the wavelength. It means what? It means that if the energy is more, lambda will be less. If the lambda will be more, energy will be less. You need, what you need? Short wavelength. Short wavelength means more energy. More energy means long line. Who has the long line? D. Simple. D has the long line. Okay, understood? Everyone understood? Okay. Okay, great. Okay, next question. The next question. In the laboratory, you dissolved this amount of the barium nitrate in the volumetric flask having 125 ml. What is the concentration of the nitrate ion? Well, this is the formula of the this is the what we say. This is the question for the concentration, which is chapter 4. Okay, which is chapter 4. One second. Okay, so what is the formula for the concentration? Wallah, but remember, they are asking about the concentration of the nitrate ion. Nitrate ion, remember, there are 2 nitrate ion present in one molecule. Okay, 2 nitrate ion. It means whatever answer will come, you have to multiply it by 2. Why? So, simple. I'm telling you, I have 150 dirhams in my every pocket. I have 150 dirham in my every pocket, and I have 2 pockets. How much money I do have? How much money I do have? Simple, 300 dirhams. The same thing here. Barium nitrate is given. Okay, no problem. But every barium nitrate has 2 nitrate. So, and I have to calculate the concentration for nitrate ion. That's why I have to multiply it by 2. Okay, so let's calculate the answer. Let's calculate the answer. Okay, what is the formula for the molarity? Formula for the molarity is, remember, given mass by molar mass, multiply by 1000 divided by the volume. Volume should be in ml. This is the formula for the molarity. Okay, so what is the given mass? 19.7 divided by molar mass for the barium nitrate. You have to calculate it. Okay, because the periodic table is with you, you can be able to calculate. Okay, so the answer is 261.337 multiply by 1000 divided by, what is the volume? 125 ml. This will be the concentration for what? For barium nitrate. But what I want to know, only nitrate ions. Tell me what I will do now. Tell me what step. Yes, very good. Multiply by 2. Now I will multiply it by 2 and I will get the answer. This is for concentration. Okay, for concentration. Okay, did you understood this? Did you understood the question? Did you calculated the answer? Very good. Everything going very smoothly? Are you confused or everything fine? Don't worry, I will send you the YouTube link of this lecture. Don't worry, I will after finishing. It's okay. Okay, now let's move to the next question. Now, oh well, there are more MCQs. 2 more MCQs, no problem. The question of precipitation. The question of precipitation, chapter number 4. For this one, you must know the few things which is called the precipitation table. Okay, you must know about the precipitation table. Let me share some precipitation table with you, and I will tell you how to use it. Okay, how we will be able to solve these kind of the questions? Remember, guys, remember, for these types of the question, just check the negatively charged ions like sulfate is here and chloride is here. If I will mix each other, will they form the precipitate? They are asking this. So remember, this kind of the reaction is called double replacement reaction or double displacement reaction. In this reaction, when this molecule is reacted with this one, so two things are formed. Voila, they will just exchange their partners. Okay, so it will be MgSO4 and ZnCl2. They will just exchange their partners and they are doing nothing. Okay, now see, I have to check, is sulfate is making the precipitate with magnesium or not, or chloride is making the precipitated zinc with or not. Let's check with the sulfate. Sulfate are always soluble except silver, lead, mercury, calcium and barium. So it will only form precipitate with barium, calcium, mercury, lead and silver. But this is Mg. So will they form precipitate? No, not precipitate. No problem. Let's move to the next one. Chloride. So let's check for chloride. Chloride will make precipitate with only silver, lead and mercury. But this is zinc. No precipitate also. Now, neither first or nor second will make any precipitate. That's why we will write the no precipitate will form. That's it. Okay, so this was this question. Now I'm changing the question. I have BaCl2 plus MgSO4. Okay, tell me what are the products. Tell me, I told you they will exchange their partners. Okay, so tell me what are the products. Very good. BaSO4 and MgCl2. Very good. Barium sulfate and BaSO4 plus MgCl2. Now see, let's check sulfate. Sulfate are barium. Oh my god, it means this will make a precipitate. So you will write solid here because it will be a precipitate, and this will not make a precipitate. Remember guys, remember those ions which make the precipitate and the other ions. These are the other ions. It will be called spectator ions. Okay, it will be called spectator ions. So these are the precipitate. The barium sulfate will be the precipitate, and magnesium and chloride, they will be the spectator ions. Now I want to write the net ionic equation. For the net ionic equation, only for precipitate, okay, it is made up of barium 2 plus and sulfate 2 minus. It will form BaSO4 solid. Khalas, tamam, only this. Okay, this will be the net ionic equation. Okay, did you understood? Shall we move? Okay, let's move to the next question. Chapter number 19. Chapter number 19. Okay, so chapter number 19. It looks like it is very difficult, but don't worry, it is not very difficult. Okay, check. Here, for this concept, you must know what is oxidation, and what is reduction. What is oxidation? Oxidation is the lose of electron. Reduction is the gain of electron. Lose of electron means the oxidation state is increasing, and gain of electron means oxidation state is decreasing. Oxidation state means the charge there. Now tell me guys, if I talk about the tin is going from +4 to +2. Oxidation state is decreasing, so it is oxidizing or reducing? Tell me, it is oxidizing or reducing? Tell me, it is oxidizing or reducing? Yes, I can repeat. There are two important things here. The first is the oxidation and the second thing is reduction. Oxidation means it is losing the electron, it is removing the electron from it, and the charge here is increasing toward the positive, like +2 to +4, increasing. That is the oxidation. Reduction means gain of electron. Gain of electron means they are accepting the electrons. Okay, they are accepting the electron. Accepting the electrons means the oxidation state is decreasing, like in tin in this question. It was +4, now it is decreased to +2. So this is reduction. This is accepting 2 electrons. But if we talk about the chromium it was 0, but now it is increased. This is oxidation. So here chromium is oxidized and tin is reduced. This is reduced and this is oxidized. Okay, now listen. For the question for the E cell, the formula for the E cell equals to, one second, yeah, it is, the formula for this is equal to reduction minus oxidation. Reduction minus oxidation, always. Okay, reduction minus. So tell me, who is reducing? Tin is reducing. So what is the value for tin? This 0.15 minus. What is for oxidation? 0.74. So minus 0.7. Tell me the answer. Tell me the answer. Okay, I will repeat. Don't worry, I will repeat. Don't worry, I will repeat. Tell me the answer first. Answer. Yes, 0.89. Very good. 0.89. This is the answer. Listen again. Oxidation means the charge is increasing. Oxidation means the charge is increasing. Reduction means charge is decreasing. That's it. If the charge is increasing, it will oxidation. If the charge is decreasing, it will be reduction. You can say either charge. Normally here we say the oxidation state. Okay, normally we see in this chapter we say oxidation state. So for this, if the oxidation state is increasing, it is called oxidation. If the oxidation state is decreasing, it is called reduction. voila, oxidation state increasing, oxidation state increases. Okay, like that. So and the formula is reduction minus oxidation. This E reduction minus E oxidation, like that. E reduction minus E oxidation, like that. Okay, let's move to the next question. Let's move to the next question. Okay. Important question from chapter number 3. Now see, remember, here calcium chloride is added to this. Okay, first we have to check, first we have to write the balanced chemical equation. Voila, remember, it will exchange its partner. Okay, no, not a big deal. So calcium will attach with the nitrate and chloride will attach to the silver. So one thing you remember, how to separate the salt and how to make them again. It is CaCl2. Okay, if we talk about the CaCl2, remember, the whatever is given here, it will go to the top of the another atom, like this. So it will be calcium 2 plus and Cl minus. Okay, but for AgNO3, you will say, sir, 3 is here. No, my friend, NO3 is a single molecule, nitrate is a single molecule. Okay, so it will be simple Ag plus and NO3 minus. Okay, so now Ag will make with nitrate, calcium is with chloride. Now they will exchange their partners. The Ag will come with a Cl, so it will be AgCl. Okay, and the calcium will again with the nitrate, so calcium 2 plus and NO3 minus. So what will happen, if the polyatomic ion needs something here, so it will make in the bracket, so it will be CaNO3 in bracket and 2 will be here, calcium nitrate, like this. Okay, so this will be the item. Now when you will write them, you have to balance the equation. It is super simple. How? At the left side you can see, oh my god, there are 2 chlorine, but it has only 1 chlorine. Just put 2 here. When you put 2 here, 2 silver are here, just put 2 here, and finally it is balanced. Everything is balanced now. Okay, the Zoom session is ended. Let me start it again. Let everyone join. Okay, let's start it. Okay, so finally we have got the balanced chemical equation. Now I have to calculate how much mass of the AgCl is produced. How I will do this? Okay, how I will do this? Now, one thing also you remember. For this question, AgCl, when you will check the what table was that? The precipitation table, you will see that Ag and Cl will make a solid, so it will be precipitate. Okay, so these things you have to remember when you will write the chemical equation. First, just exchange the ions and write it, and just finally check who has the precipitate or not, and then finally balance the equation. You will get the full marks here. Okay, now let's move to the second part. Second part says that how much mass of the AgCl produced. So remember, to get the mass or the theoretical yield, something like that, or the limiting reagent, or like something like that, remember, for this is the question of limiting reagent and theoretical yield. Okay, now see how to solve the question of the limiting reagent very fast. See, for the mass of the AgCl produced, okay, first you will check how much you have AgNO3 and how much CaCl2 you have. Okay, how much AgNO3 you have and how much this you have. Okay, now what we will do, after first we will check how much calcium chloride we have, CaCl2. To check how much calcium chloride, just to get the number of moles, which is equals to M1 multiplied by V1 divided by 1000. This is how you will calculate the number of moles of calcium. Okay, so it will be 0.15 multiplied by 30 divided by 1000. Okay, and tell me the answer. Also for silver nitrate, how much it is? So it is very simple, N2, which is equals to M2 multiplied by V2 divided by 1000 equals to 0.1 multiplied by 0.15 divided by 1000. Calculate the answer for both. Tell me the answer for both. 1.5 into 10 to the power minus 5. Okay. For this one, it is 1.5 into 10 to the power minus 5. Okay. How about this one? This. Okay, now we have got the moles of both. Let's move forward. Okay, AgNO3. Remember, see this. One calcium chloride is making double AgCl. One calcium chloride is making double AgCl. So this will make double of this. It means 9 multiplied by 10 to the power minus 3 of AgCl. Okay, about this one, same amount, yani 2 AgNO3 is giving 2 AgCl. It means if the 1 AgNO3, 1 AgCl, 1000 AgNO3, it will give 1000 AgCl. First we compare this and this. Now we are comparing this and this. Okay, now it means that the number of moles for this, it is 1.5 into 10 to the power minus 5. Simple, 1.5 into 10 to the minus 5. Now see, who is the limiting reagent? Remember, this mole and this mole is the number of moles of the AgCl. Who is the limiting reagent? Limiting reagent is that reagent which will make this product in less quantity. The limiting reagent is that one which will make the product in less quantity. Who will making the less quantity? Well, this one. That's why AgNO3 is the limiting reagent. AgNO3. Okay, no. Okay. Yeah, no problem. First step I calculated the number of moles of everything. Okay, first I calculated the number of moles of calcium chloride and then AgNO3. Second step, I converted the moles of the reactant to that of the product. How? See, one AgCl, one calcium chloride is giving 2 AgCl. Okay, so whatever moles of the calcium chloride will be, it will give the double amount. How you get the number of moles? The formula for the number of moles is equal to M1 V1 divided by 1000. Concentration multiplied by volume divided by 1000. This is the formula. Okay, this is the formula. Understood? Where yes. I'm dividing 1000 to convert milliliter to liter. Yes. Okay. First, for the question of every limiting reagent and theoretical yield, the first step is to convert everything to mole. Okay, everything to mole. Second step is to convert the mole into the product. Like the calcium chloride is giving double. Okay, calcium chloride is giving double AgCl, so I will multiply by 2. Simple. But AgNO3 is giving same, so that's why the mole of the AgNO3 is equal to the same of the product. Simple. So these blue marks, 9 into 10 to the power minus 3 and 1.5 into 10 to the power minus 5, this is the moles of the AgCl which can be formed from calcium chloride and AgNO3. Now I have to check who is the limiting reagent. The limiting reagent is that okay, first listen this. At least first listen this. I will tell you. These are the tricks which will be help. Why we are taking too long? We are taking a lot of time because I'm understanding. I'm making the understanding, making you understand these questions. I'm teaching this. That's why I'm taking a lot of time. Okay. When you will solve this, wallah, it is the game of few minutes. I told you the step one for every question of the limiting reagent and this theoretical yield. The first step is to convert moles, okay, from mass or everything to the moles. The first step is to calculate moles. Second step is to convert the mole of the reactant to the mole of the product. Okay, from the reactant to product. Now the third step, who is the limiting reagent? The limiting reagent is that who will make the product in less amount. Tell me who is the limiting reagent? Which both of them, who has the less amount of the AgCl will formed? Very good. The 1.5 into 10 or AgNO3, silver nitrate. Yes. That's why the silver nitrate is what? Limiting reagent. Final step is to convert the mole of the AgCl to the gram. Okay. Final step is to convert the moles into gram. Formula. Just multiply the 1.5 into 10 to the power minus 5 into the molar mass of AgCl. That's it. The multiply the moles of this mole, this one. Okay, this value multiply the molar mass of AgCl, you will get the mass of the final answer. Okay, this is how. The first step, convert everything into the moles. Second step, convert those moles, yes, the mass into the moles. Okay, the second step is moles of the reactant to the moles of product. Third step, check who is the limiting reagent, and who is the limiting reagent which will make less amount of the product. Okay, and then finally whoever is the limiting reagent, okay, check who has like this value, this value has the final one, so just multiply this by the molar mass of the product, you will get the answer. Always, yes, it will be always, it will never change. Every question, voila, in LX, in final exams, everywhere, even when you will do the experiments in laboratory, same thing will be applied. This is applied everywhere. Now you understood? Now you understood? Wallah, I am 100% sure if you will complete understand this paper, you will not be able to, you will not need more questions or something like that, because right now the only confusing part is they are asking about the AgCl. They are asking about the AgCl because wallah, it is the product. Okay, it is the product. Wallah, they need the theoretical yield of AgCl. How can I think that they need compounds, other compound moles? See the B part. Check, read the B part. It need the gram of AgCl. Read the B part. It is in the question. Wallah. See, I am teaching you this. I am not teaching you the organic chemistry. I am not teaching you the very advanced chemistry. You need this chemistry 115, and I am teaching you this. So the answer need the gram of AgCl. So you will give the answer. The answer is 2.15. I think you are correct. Very good. Very accurate answer. Very accurate answer. This is the answer, 0.215. Okay, let's move to the next question. Let's move to the, one second, next question. She is asking how we are calculating the mass. To calculate the mass, it is simple. Just multiply this, multiply the mass, multiply the number of moles by the molar mass. That's it. Okay, this is how you will calculate the mass. The question like this. Question like this. See, it is given, and you have to calculate. I'm just marking them so that we will do the questions. Okay. Magnesium phosphate. Magnesium phosphate. This is an ionic compound. Okay. So ionic compound, magnesium phosphate, Mg. Magnesium is Mg2 plus, and phosphate is PO4 3 minus. Okay. So simple. Just make the ions. So it will be Mg3 and bracket PO4 2. This is the first one, magnesium phosphate. The second one, sir, I have seen everything, but why we use this Roman number? Every time many students ask, sir, why we use this Roman number? My friends, we use this Roman number. The reason of using, oh, you cannot see the board? Now visible? Now visible? Okay, cool. Okay. So for the first one, it is magnesium phosphate. The magnesium is Mg2 plus and phosphate is PO4 3 minus. It is nothing but the exchange of the ions. 2 will go at the bottom of the phosphate and this 3 will go at the bottom of magnesium, and this is MgPO4 magnesium phosphate. I was talking about this one, why we use this Roman number while writing the name of the few compounds, few ionic compounds. For the name of the few ionic compounds, we write it because there are few ions, there are few cations which have multiple valencies. Multiple valencies means, for example, iron. Sometime iron is 2 plus and sometime iron is 3 plus. Wallah. Sometime tin is 2 plus and sometime tin is 4 plus. Sometime let us consider scandium. Sometime it is plus 1 and sometime it is plus 3. Oh my god. Two valencies. What we will do? For these one, we will do like this. Okay. They are talking about titanium 4. So titanium 4 means Ti4 plus, and oxide. Oxide is always O2 minus. So when we will do this, Ti, so Ti2O4, if they are divisible, so just cancel 2 and 2 here. So it will be TiO2, titanium oxide, TiO2, like this. Okay. The next one, AlBr3, aluminium. Aluminium has only plus 3 everywhere, always plus 3. So we do not need to write the Roman number, just simple aluminium bromide, that's it. Only aluminium bromide. When do I use the prefix? Very good. When you will use the prefix, you will use the prefix whenever you have non-metal and non-metals. Whenever you have I will complete this, then I will share some examples for the prefixes. Okay, don't worry. The next is ammonium sulfide. If we talk about the ammonium sulfide, ammonium is NH4 positive and sulfide is S2 minus. This and this. So simple, it will be bracket NH4 2 and S. This is ammonium sulfide. Why I am using the bracket? Bracket will be used on polyatomic ions. Who polyatomic ion means? Ammonium, phosphate, ammonium, or let's talk about the nitrate NO3 minus or sulfate SO4 2 minus. They are the polyatomic ions. For them we use the brackets. Okay, and the last one. For the last one, it is very simple. This is calcium sulfate, no problem. Calcium always 2 plus, sulfate always 2 minus. So it is CaSO4, calcium sulfate. So calcium sulfate, and the last one is 2H2O. For this H2O, you remember, if one H2O, then mono. Just we will write them first. For 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Okay, it will be like monohydrate, dihydrate, trihydrate, tetrahydrate, pentahydrate, hexahydrate, heptahydrate, octahydrate, nonahydrate, and decahydrate. This is how we will be able to name these types of the compounds. Let's move for the prefixes. Whenever we have non-metal and non-metal, it will always have a prefix. For example, CO2, carbon dioxide. Okay, P2O4, diphosphorus tetraoxide. Okay, let's move forward. Cl2O7, dichlorine heptoxide. Okay, dichlorine heptoxide. Remember, the name of the first compound will be complete: carbon dioxide, phosphorus, diphosphorus tetraoxide, dichlorine the name of the first one will be full, and second name will be ide, ide, chloride, bromide, iodide, oxide, nitride, carbide, sulfide. Okay, it will always be ide if only one atom. Okay, if only one atom. Let's talk about the oxo ions. Oxo ions. For the oxo ions, it is of, normally it is made of the halogens. Halogens are chlorine, bromine, fluorine or iodine. Not fluorine, chlorine, bromine or iodine. It have four forms. It is like HClO, HClO2, HClO3 and HClO4. These are the acids, and if this is ClO minus and ClO2 minus, ClO3 minus and ClO4 minus, if this are here, okay, and if these are here, how we will name them? Okay, for this only one oxygen will use always hypo, and for 4 it will always use per. Okay, this is perchloric acid. This one only chloric acid, this one chlorous acid, and this one hypochlorous acid. But here it is something different. This is perchlorate, this is only chlorate, this is chlorite, this is hypochlorite. What is the important thing here? Hypoous acid, us, ik, per, ik. For example, not this is not Cl. Let us consider this is Br. Simple. Hypobromous acid, chlorous acid, chloric acid, bromic acid, perbromic acid. If we talk about this, let us consider iodine is here. So hypo, iodate, iodate, periodate. Okay, these are the rules for naming. Yes. When I do per 8. Now you understood when you will use per 8 for this one, ClO4 minus, perchlorate, ion. This is ion. It can be with cation and anion. Okay, let's move to the next question. This is the next question. Chapter number 9. Okay, the compound is here, and the Lewis structure is also here. You have to calculate the domain or geometry. Electron domain. Remember, electron domain. There are two different things. The first is the electron domain, and the second thing is geometry. Everything depends on the number of moles and the lone pair on the atom. For example, if we talk about this one, okay, wait 1 second. This is an important image to solve the to solve everything related to chapter 9. Okay, see, what are electron domains? What are electron domains? Remember, the electron domain are bond plus lone pairs. Tell me, if we talk about the central nitrogen, it has 3 bond plus 1 lone pair, it is total 4. Okay, let's come to the 4. 1 2 3 4. For 4, the electron pair geometry, it is tetrahedral. That's why it is tetrahedral. Voila, this image is important. If you want, just take a screenshot of this, and if you want, ask me, I will send it to you. Okay, I will send this to you whenever you need. Okay, you have to remember these things. Okay, now molecular geometry. For molecular geometry, if it has 1 lone pair and 3 bonds, okay, let's see. If no lone pair, then same tetrahedral, but if 1 lone pair, it will be trigonal pyramidals. That's why it will be trigonal pyramidal. Okay, this is trigonal pyramidal, and that's why. And the last thing is, this molecule is less symmetric. Trigonal pyramidal means 1 nitrogen at the top, 1 fluorine here, 1 fluorine here, and 1 fluorine here, like this. So this molecule has something up at different and something here at very different. This will create 2 poles. Okay, this will create 2 poles, and that's why it will be a polar molecule. Okay, now check for AlCl3. Check for why tetra. Someone is asking why tetra. For why tetra? Okay, tetra means 4, and 4 it has 3 bonds and 1 lone pair. That's why it will be tetra. Okay, and let's talk about the next one. So voila, it is simple. It has only 3. We will only check the central atom. Only check. So the central atom, okay, it will be trigonal planar. Yes, it will be trigonal planar. Is there any lone pair? No lone pair, so it is the same trigonal planar. And see, it is completely symmetric from all sides. Symmetry, symmetry, symmetry. Everything is same from all sides. So that's why it will be non-polar. If it is same from all sides, if it is symmetric, it will be non-polar. And if it has differences in some kind here and sometimes here, it has differences, it will always be the polar. Okay, it will always be the polar. Remember one thing, never they will give you very complicated molecules. They will give you very easy and very simple molecules, so don't worry about this. These are the very simple molecule. The main thing, the most important thing here is nothing but the table what I gave you here. Only the table is very important. Okay, let's move to the next part. Let's move to the next part. This is also the part of the chapter 9. This is also the part of chapter 9. First we will do the first part. See, you have to calculate the formal charge. Okay, formal charge. The formal charge, the formula for the formal charge is the electrons the valence electron minus the electron in structure. For sulfur it has 6 valence electron. Okay, for sulfur it is 6 valence electron, and the how much electron are given in this? 1 2 3 4, and every bond has 1 electron of each atom. It is like this, it is like this. So 1 electron is related to sulfur here and 1 electron for sulfur here. So total it has 6 electrons. So 6 minus 6, yani it is 0. Let's talk for nitrogen. Nitrogen has valence electron 5. Okay, and 1 electron, each electron in its bond here. So total 5 electrons are here. So 5 minus 5, it will be 0. So nitrogen and sulfur, it will both have 0 formal charge. This is the first part of the question. Come to the second part. Come to the second part. They are asking the bond angle about the sulfur and nitrogen. Okay, they are only talking about the sulfur and nitrogen, but I will do for every atom. I will do for every atom. You have to remember few things. If 4 electron domain, it will be 109.5. If 3 electron domain, it will be 120. If 2 electron domain, it will be 180. What are electron domain? Electron domain are the lone pair plus bond. Now which bond? For example, if we talk about this carbon, she is asking how much question is left. Few questions are more. I'm trying to finish as soon as possible. Don't worry. I know it's time for you to sleep also, because tomorrow in the morning 7 I have my own final exam. And see, right now I'm teaching you, I'm not studying for me, so say thanks to me. Okay, right? So tomorrow I have my final at 7 o'clock in the morning, and right now it's almost 12 o'clock. Okay, so we are going to finish this very soon, inshallah. Okay, so these are the things. For example, if we want to calculate for this, so this carbon, has 1 bond, 2 bond, oh my god, double bond, but I will consider it only 1 electron domain. I will consider this only 1 electron domain. Either it is single bond, either it is double bond, or either it is triple bond. It will only considered as a 1 electron domain only. Okay, so tell me, for this carbon, what is the angle? Tell me, for this carbon, what is the angle? Everyone, for this carbon, 3 electron domain, 120. Simple. 3 electron domain is 120. Okay, let's talk about the second one. Let's talk about the nitrogen. See, nitrogen has 1 domain, 2 domain, 3 domain, and the fourth is the lone pair. 4 electron domain. What is the bond for 4 bond angle? 109.5. So it is 109.5. Let's talk about the sulfur. Sulfur, 1 domain, 2nd domain, the 3rd domain is here, and the 4th domain is here. So 4 electron domain, again 109.5. Let's talk about this carbon. So 1 electron domain, 2nd domain, 3rd domain, and 4th domain, again 109.5. Let's talk about an example. If I have this carbon and having a triple bond carbon and have one H and H. So tell me, what will be the bond angle of this carbon? Tell me, what will be the bond angle of this carbon? How much electron domain will it have? Very good. 2 electron domain, 180. Simple, very simple. Okay, this will be the very simple question for you. Now chapter 9, you are good at your chapter 9. Okay, we have completed the chapter 9 everything, and this is the thing we are going to calculate for the bond angle. Let's move to the next question. Next question. For this one, you have to find the smallest radius and the highest second ionization enthalpy, 3 valence electron, and 2 unpaired electron in the total orbital diagram. Okay. See. Let's talk about the first one, the smallest atomic radius. First check. Everyone is in the third shell. Yes, everyone is the third shell. So remember, the atomic radius is directly proportional to the electron in the final shell. Atomic radius is smaller the radius, greater number will be the electron. More number of electron, smaller radius. Okay, so for third one it has only 1 electron. For third it has 2 and 1 it is 3 electron. 2 and 4 it is 6 electron, and for 2 and 5 it is 7 electron. So tell me, who will have the smallest radius? Voila, the one having the highest number of electron in the final shell. We are only talking about this final, the third one, only the third one. So this is D. Second highest ionization enthalpy. What does this mean? Second highest, it means the first is the small and the second is very much. It means first is small, second is too much. What does that mean? It means that first electron can be removed very easily, and after that no electron will be removed. Tell me, for everyone whose first electron will be removed very easily and second electron is almost impossible. See, here first electron can be removed very easily, but after that it is impossible to remove the electron. That's why it will be A. 3 valence electron. It is very simple. We already wrote 3 valence electron. It is B. 2 unpaired electron in the orbital diagram. 2 unpaired electron. So for this one we will make S and P. S and P. S and P. And so on. S and P has 3 boxes, S has 1 box. Now I will fill the electron. This is 1s. It is only 1 unpaired electron. Okay. This is 3s2, 3p1, 3s2 and 3p1, 3s2, 3p4, 3s2, 3p1, 2, 3 and 4, and 3s2, 3p5, 3s2, 1, 2, 3, 4, 5. Tell me which of the following may have 2 valence electron, which is unpaired, 2 unpaired electrons, 2 unpaired electrons, and it is related to C. One second. Okay, 1 second. Okay, so let's move to the next question. Okay. Let's move to the next question. How many left? Wallah, a lot. A lot. Okay. See, for this question, the mole is given. Okay, for this question, the mole is given, and the temperature is given, the heat is given, final temperature is given, specific heat it is this, and use your knowledge about the heat transfer and how much. What you have to identify the metal. Identify the metal means you have to calculate the molar mass or the atomic mass of the metal. Atomic mass. Okay. How we will do this? If the heat is given and the specific heat is given, when we always use formula heat, or Q is equals to MC delta T, or here it is S, so we will use S, MS delta T. So Q is 2250 is equals to, mass is not given, which we have to calculate the mass, and S is 0.449, and what is delta T? 32.8 minus 18.2. Okay, so the mass is equals to 2250 divided by 32.8 minus 18.2 multiplied by 0.449. Tell me what is the mass? Please tell me what is the mass. $343.23. It is 343.23. Now we know that number of moles is equal to given mass by molar mass. So molar mass will be equals to the given mass by number of moles. So just easy, divide this value by the number of moles. Divide this by 6.145. Tell me the answer. 6.145. Tell me the answer if we divide it by the number of moles. 55.85. So the answer is 55.85. Remember guys, it is almost equal to 56. Open your Quran and search for chapter number 56, and that is Surah Al-Hadid, and which means iron. Simple. This is one of the miracle from Quran. So also just 55.85, it is the molar mass of the iron. Okay. Yeah, it is one of the important, one of the wonders of Quran, right? So yeah, cool. Why did we divide it by 6.1? Because this 6.145, this is the mole. Okay, see here, See here, the molar mass is equal to given mass by number of moles, and number of moles is already given in the question. 6.145 is the number of moles which is given in the question. See, 6.145 is the mole which is already given in the question. Okay. Let's move to the last question for today, because it's already 12 o'clock and tomorrow I have to wake up at 6 for my final exam. Tomorrow I have my final exam. I'm telling you again because I am also depressed like you, but well, I'm not too much worried. Inshallah, I'll study. I will try to. You have to assign the oxidation state for each of the underlined atom. Okay. Few things you have to remember. To determine the oxidation state, if the molecule is neutral, it has no charge, so it will always be equals to 0. And what is the charge for hydrogen? For hydrogen, it is always +1. Remember, for oxygen, it is always -2. For alkali metals, alkali, who are alkali? Hydrogen, lithium, sodium, potassium, cesium, francium, it is always +1. For alkaline earth metal like beryllium, calcium, strontium, barium and magnesium, it will always be 2+ or +2. Okay, let's come back. So it is just like you calculate the total molar mass na, it is exactly like this. It is like for hydrogen it is +1 multiplied by 2, and what you want to calculate, like for S you want to calculate, just put it x plus x. So tell me what is the answer for x. It is 2 plus x is equals to 0, and x will be equals to -2. So here for -2 for sulfur. Let's try to calculate for this. Sodium here it is +1, so +1 multiplied by 2 okay, plus x plus -2 multiplied by 4. Tell me the answer. Equals to 0. Okay, tell me the answer. It will be 2 plus x minus 8. So x will be equal to plus 6. It is plus 6. Okay, for this calculate by yourself. Calculate by yourself and tell me the answer in comment box. Calculate by yourself and so we need to get the yes. It is nothing, it's directly the addition, like you calculate in the molar mass. Okay, like 2 multiplied by H, okay, plus sulfur will be in underline, and for oxygen it will be -2 multiplied by 3 and it will be equal to 0. Tell me what is the answer. For these question you have to remember, do not tell me only figure. It should be either +4 or -4. Okay, because that plus minus is very important. So yes, that the answer is +4. The answer is +4 for this. Allah. Okay, so shift this. One more question is left only. One second, let me explain this one. First, let me explain this one, the last one. It is for h, it is 1 multiplied by 2, okay, plus 1 multiplied by 2 plus x, okay, and for this it is minus plus minus 2 multiplied by 3 equals to 0. So it will be 2 plus x minus 3 minus 6 equals to 0. So x minus 4 equals to 0. So x will be equals to plus 4. Simple. That's why it will be 4. Okay, the last question here. What is the shorthand diagram, which is already written here, but for the MO2 plus, molybdenum 2 plus? First tell me where is the molybdenum in the periodic table. Let me show you the periodic table. Wait. Here is the periodic table, okay. You have to check MO2 plus, okay, for MO2 plus. Here we have MO2 plus, okay, here. So it is 5s, 5s and 2 are here, and 1, 2, 3, 4. 4d4. And what is before 5s? 5, just 5s, it is before krypton here. So it will be Kr. This is the shorthand electronic configuration for MO only, MO, molybdenum. But it is 2 plus. Always remember guys, whenever you find this type of the diagram, 4d and 5s, whenever you want to remove the electrons, okay, first electron will be removed from s, always. Always, 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 the electron will be removed from s, always. Okay, when we talk about this 5, 4, like 4, 3, okay, it is simple thing. The outer thing, obviously, it is like 1, 2, 3, 4, 5. So 5 is the outermost, na? So outermost, from the outermost, 2 electrons will be removed. So it will be 4d4 and 5s0. And that's why we will make it like for d, 5 boxes, and 4 electrons are here. So 1, 2, 3 and 4. 4 electrons are here, and 5d will be 0. And this is how you have finished the this one. Okay, and right now the time is 12:05 and I'm leaving because I have to get ready for my exam tomorrow. So inshallah, all the very best for tomorrow exam, and do best. Okay, why you said 0? Okay, you are asking that why I put 0 in 5s. When see, the question is asking a MO2 plus, it means there are 2 electrons are removed from molybdenum. Okay, if the 2 electrons are removed, it means it will be removed from the outermost part. Okay, outermost means 1, 2, 3, 4, 5. 5 is the last one. So that's why from 5s2 there are 2 electrons will be removed. Yes, if for example, if molybdenum 3 plus, okay, so 2 electron from s and now 1 electron will be removed from d. First remove from the outermost and then come inside. Okay, first remove from the outermost and then come inside. So for this question, first remove the electron from 5s, then come to the 4d. Okay, now understood? Okay then, all of you, I hope everyone liked the session, and most welcome and good luck to all of you also. And right now I'm uploading this session on the YouTube and it's open for everyone, so that you will be able to send this session to all your friends, every classmate, so that everyone will take a help from this. Okay, so inshallah, see you after exam. And if you are having any problem, you can ask. I think you are having your exam at 12:30. Okay, so before 12:30, if you are getting any doubt or anything, you can be able to ask me on WhatsApp. Good night, take care, and all the very best for your tomorrow exam, inshallah. Thank you, goodbye, Assalam.